Okay, we're going to talk about growth and decay notes today. And guys, we've been studying logs now for a while. And in reality, the reason that you're going to study logs is so that you can do these problems. Okay, that's why we need logs. First of all, when I'm asking you to find a log, what are we really finding anyways? When I say what's a log, what are you finding? Yeah, an exponent. Thank you. You're finding an exponent. So the reason, though, that you need to find exponents is because basically the finance world runs around exponents, okay? And what I mean by that is this. For example, if you borrow money to buy a car, right? Or you put money in the bank because you want to retire, correct? They make these special calculators even that can say, okay, look, I want to put this amount of money in the bank and I want to leave it in there for 5 years. You know, what percent interest do I need to invest in it? Or they'll even say, you know, if I want to earn this much and I get this much interest, how much time do I have to leave in it? Okay, they have a special calculator that does all that for you. But if you don't even understand how it works, right, how are you going to use the calculator to do the math, right? So today we're going to do basic problems that show you the idea behind it. And in a couple, you're going to have to find the log. Now, in these formulas, in fact, the first formula that you see, what is the exponent? T. Thank you. It's time. So the only time that you need to use a log is if we are looking for t. Okay? So if you're looking for t, then it's a log problem. So what I mean by that is this. Okay, we've done problems like this before where it would say something like 100 equals 50t. Right? If you don't know the exponent, how do you find an exponent? What do you have to do? You have to do what to both sides? Log both sides. Right? It turns into log 100 equals log 50t. The t gets pushed in front. Right? So this is what you have. And then to solve for t, you divide both sides by the log of 50, right? So my point in that long exaggerated thing is we've studied logs, okay, so that we can find an exponent, right? So we're going to deal with all these formulas, and sometimes it requires a log to get the answer, and sometimes it doesn't. The only time it's going to require a log to get the answer is when you're looking for time. Okay, and the reason, if you flip back over and look at the formula, this crazy weird formula up here, okay, the exponent, right, which is what a log is time. Okay, so that's when you need it. All right, so let me explain what these mean, and it doesn't really matter what the letters are. Let me just kind of show you an easy way. Okay, in all the formulas we're going to talk about today, the answer is always the new. You can call it whatever you want, but the answer is your new value, okay? And this formula is something they call simple interest formula. In other words, if I put $100 in the bank and I wanted to earn 4% interest, you know, for 5 years, how much money will I have? That's what this is. Plain old, easy, simple interest. Okay? So, but the answer is always your new. Okay? The A on the other side, this one, is always the original amount. You know, I bought a car for $50,000. It's now only worth 30. What percent did it appreciate over 4 years? Something like that. The second answer is the original value, not its new, the original. Okay, and then you've got a 1. Why is there a plus and a minus?
Because it appreciates.
Yeah. If it depreciates, I need the minus. If it appreciates, I need the plus. Okay? And then the R is the rate. Have you ever heard those commercials? They'll come on for a car and they'll say, you know, buy a Chevy and you get 0% financing, right? Or 0% APR. The APR stands for annual percentage rate. R, so with the rate. Okay, what you pay. Right? The more you pay, the more it costs, obviously. So that's R, the interest rate. And in the formula, you have to put it in decimal form, guys. That's important. In the formula, you have to convert the rate to a decimal, which means you move the decimal place 2 times to the left. Okay? And then obviously, what's t? Time. Now, when you solve for time, what are you going to have to use? I just said this. When you solve for time, Time is an exponent. What do you have to use? A log. Thank you. A log. If you solve for time, you have to use a log. All right. Now, let's try a problem. Mr. Sawyer bought a condominium for $75,000. Guys, a rule of thumb on property and homes is usually they appreciate, especially property, okay? Usually your property, appreciates, not depreciates. What about a car? What does a car usually do? Depreciate until you've had it like 50 years, right? Then it goes back the other way, okay? Assuming that its value will appreciate 6% a year, which is a pretty lofty goal there, how much will the condo be worth in 5 years? Okay, so I need new and original. Well, I want to know how much it's going to be worth, so I don't know the new value. So we're going to leave an in there for new. What is the original value? 75,000. Okay, and then we want, it's going to appreciate, right? So we want 1 plus R or 1 minus R? 1 plus. So we want 1 plus, what's R? 0.06, which is 1.06, right? I'm going to go ahead and put those together, because if you can put them together in the simple interest formula, sometimes it's a little easier. You cannot put them together in the complex interest formula. And then the time was 5 years. Now just use your calculator and type that straight in. 75,000 times 1.06 raised to the 5th power. And your new value for your house is $100,000. So it was a good property to purchase. I think inflation rate is 2% a year, so technically you need 4% a year profit. Okay. Now look at number 2. 7 years ago, Phil paid $40,000 for a car. So is this the new or the old? Think about it. Okay, we'll read the whole thing. Well, yeah, you kind of have to look at the original. Is that the original price? Yeah, it's better, I guess, to think about it as original. Is the $40,000 the original? Yes, so there's my original. Its current value, okay, so its new value is now worth $8,000. Find the average rate of depreciation. Now let me ask you a question. We are solving for rate. Are we going to need to use a log? Look at your formula. If I'm solving for rate, am I going to need to use a log? No, because it's not an exponent, right? You use a log if you're looking for an exponent. So let's type in what we know then. It always starts with a new, which is 8,000. If you get new and old mixed up, you know what happens? It changes your sign. You would get a negative instead of a positive. And if you think about common sense wise, you'll understand it. So new is 8,000, this is 40,000. And then it says find the average rate. So we don't know. Are we going to do 1 minus R or 1 plus R because it depreciated? 1 minus. And how long, guys? 7 years. Okay. You might write yourself a little note that you're solving for R here because it's a tiny bit harder. So here's my R. I highlighted it because I want to try to get R by itself. Take really good notes on this part for the steps because here's the deal. I'll give you partial credit if you write this equation out because half of you are going to be able to get this perfectly. Finding R, a little more tricky. Okay, so the formula is important. To get R alone, I have to get rid of the 40,000, the 1, and the 7. What do you think I need to get rid of first? Good, the 40,000. So divide both sides by your 40,000. So 8,000 divided by 40,000, and the calculator gives you 0.2. Okay, so I'm looking for R again. So what number do you think I should get rid of now? The what? The 1 is in parentheses and it belongs to that 7, doesn't it? I can't just subtract 1. What do you have to get rid of first? 7. How do you get rid of the 7? You take the 7th root, right? Or you raise it to the 1/7 power. Okay? So I'm going to get rid of this by raising it. I'm going to raise this to the 1/7 power, and that will cancel. And then you raise this to the 1/7 power. Whatever you do to one side, you have to do to the other. So in your calculator, do me a favor and do 0.2 raised to the 1/7 power. You need to all do it, because if you're not getting it right in your calculator, it's going to be harder. Yeah, I got 0.79. Okay, we're solving for r still. We're trying to get r by itself. So what's the next step? Subtract 1. Okay? And you get negative 0.21 equals negative r. So what does r actually equal? What was the rate that it depreciated? Well, right, which is 21%. So, guys, that's a lot. That car has depreciated 20% a year. Yep, it did not retain its buying power. Okay? All right, number 3. Number 3. A painting appreciated in value from 3,000 to 4,500. Okay? In 5 years. Find the average annual rate of appreciation. What letter are we looking for? Find the average annual rate. What letter are we looking for? R. Are we going to need to use a log? Look at the formula. Is R an exponent? No. So are we going to need to use a log on this one? No. Okay, so fill it in. Try to fill in the formula. Remember, if you mix up original and new, you're just going to get a negative percentage instead of positive. So be careful. On these type, yeah. So the original price was $3,000 and the new price is $4,500. So it looks like this. And then we're going to do annual rate of appreciation, so 1 plus R. We don't know R. In 5 years. So again, we're solving for R, so R is not an exponent, so we are not going to need a log this time, right? We'll get to where we need a log in a second when it's asking for time. So the first step is to do what to both sides? We got to get rid of the 3,000, the 1, and the 5. What do we get rid of first? Not subtract. Divide. Yeah. It's okay. Divide by 3,000. So you get 1.5 equals 1 plus r to the 5th power. What is your next step? Do we get rid of the 1 or the 5? The 5. By raising it to the 1/5. So now I have 1.5 raised to the 1/5 power. Try it on your calculator to be sure you're understanding it. And you get 1.08. Then you subtract 1, and R is 0.08. So what's the rate then? What's the actual rate? 8%. So that art painting appreciated 8% a year. Okay, read number 4, please. Okay, it's a less call, right? And it's gonna obviously, increase in value. They think that it's gonna increase by 14% a year. In what year will the guitar be worth $60,000? What variable am I looking for this time? T. When you're looking for time, you're looking for an exponent. And when you're looking for an exponent, what do you have to do? Log. Finally, the log is coming into place. While we've been studying logs, it's to find time, okay, in any of these types of problems. So set your formula up. Okay, originally it was worth 12,000. So you start with the new value. So it's $60,000 is the new. Originally they're saying it was worth 12,000. 1 plus 0.14. Now guys, when you have both 1 and 1.4, I like to erase it and just write the answer there. It's going to make these problems a lot easier. Just see what I'm saying? If you've got both, I would put both there, just the final answer. And then I don't know time. Okay, any time you're looking for time, okay, you have to do a log. So what's my first step? Is it to multiply the 12,000 and the 1.14 or divide by the 12,000?
Divide.
Good. You're not going to multiply those. That 1.14 belongs with time. You can't multiply that. Okay, so you're going to divide both sides by 12,000. And you get 5 equals 1.14 time. And now it looks just like a problem that we've been doing on quizzes and homework and all kinds of stuff. I'm looking for an exponent. I log both sides. Okay? Because what you'll do, and I'm going to bring it up here, you're going to log this side and log the other side. The property says that if you log it and have an exponent, it pushes it in front. So what you really have is log 5 equals t log of 1.14. So now divide both sides by log of 1.14. How many years? A little over 12? So depending on how your brain thinks about it, okay, time was 12.3 years. So I would accept 2012 and 2013. Either way out, I would accept it. Because it asked actually in what year. Okay, the next one, number 5. The value of a truck bought new for $28,000 decreases each year by 9.5%. When will the truck fall to $5,000? Try to set it up on your own. The original is what? What's the original? Yeah, 28,000 was the original. The new is 5,000. It decreased, so we're going to use 1 minus 0.095, which is 0.905. Again, which part? Yeah, I got 0.905 because it decreased. So here it's supposed to be 1 plus the rate or 1 minus the rate. So 1 minus 0.095, you have to move the decimal 2 places. I'll give you 0.905. So to solve for time, it is an exponent. That means we're going to use a log. So first, let's divide both sides by your 28,000. So you get 0.1785 equals 0.905t. Okay, now then again, I'm solving for a variable, so what do you do to both sides? Log it, right? So you can write log 0.1785 equals log 0.905t. And what do we do with that t? The t ends up going in front, doesn't it? So what you have is log of 0.1785 equals t log 0.905. 17.25 years.
That's very good.